Hello student, today we are going to discuss about the variable speed or non-uniform speed. In last class we studied that when a body moves different distances in equal interval of time, the body is said to have non-uniform speed or variable speed. Now, what is the equation of motion for that variable speed? In that case, s is t square plus 2. So, in order to define this type of variable speed, the power of t must be greater than 1. If the power of t is more than 1, so it represents the variable speed. So similarly, distance is the dependent variable. Every value of s depends on value of t. T is independent variable. T is in second, distance is in meter. When t is equal to 0, so according to this equation, what is s? S is 2 meter. T is 1 second, s is 3 meter. T is 2 second, s is 6 meter. And 2 square means 4. T is 3 second, 11 meter, T is 4 second, 18 meter. Now if you see the difference of distance, so that interval is not constant. 3 minus 2, 1 meter, 6 minus 3, 3 meter, 11 minus 6, 5 meter, 18 minus 11, 7 meter. That means in equal interval of time, the body covers different distances. In this particular case, the distance travelled by the body in successive equal intervals gradually increases. So what is speed during the interval 0 to 1 second? It is 1 meter per second. 1 to 2 second, you just see, it is 3 meter per second. Then 3 to 2, what is 3 to 2? Delta x by delta s by delta t. What is the value of delta s in the time interval 3 to 2? Delta s is 3 to 2. So this is 3, this is 2. 11 minus 6. 11 minus 6 is 5. 3 minus 2 is 1. So 5 meter per second. What is the speed in the time interval 3 to 4? What is delta s? 3 to 4. 18 minus 11. 18 minus 11 is 7. So 7 meter per second. So if I take the interval 0 to 4 second, 0 to 4, at t is 0, distance is, position is 2 meter, at t is 4 second, position is 18 meter. So what is change in distance? What is the distance travelled by the body? It is 16 meter. What is time? 4. So it is 4 meter per second. So if I take the interval 1 to 4 second, at t is 1 second, s is 3 meter, at t is 4 second, s is 18 meter. So 18 minus 3 by 4 minus 1, so it is 5 meter per second. That means, if we take equal interval up to this point, then ratio of distance travelled to the time taken is not constant. In this particular case, it is gradually increasing. But if we take the different intervals of time, 0 to 4, 1 to 4, 3 to 4, then speed of the bodies are different. Therefore, this is the condition of non-uniform speed or variable speed. So there may be different conditions or different cases of variable speed or non-uniform speed. In our real life, there may be different conditions or different cases of variable speed. So this is one of the examples. So what is distance time graph for the variable speed or position time graph for the variable speed? This is the position time graph for the variable speed. Because at t is 0, s is 2 meter, at t is 1 second, s is 3 meter, then s is 3 second, 2 second, it is 6 meter, at t is 9 second, 11 meter, therefore it increases in this way. That means when a body moves with variable speed, so distance time graph is not a straight line. or position time graph is not a straight line. It is অলপ কি হ'ব curved হ'ব, বেকা হ'ব. Whenever a body moves with variable speed or non-uniform speed, the distance time graph is not a straight line, it is a curved one. But in this particular case, what is speed time graph? So speed time graph is a straight line inclined to time axis. Speed time graph is a straight line inclined to time axis. Because at the end of 1 second, it is 1 meter per second. At the end of 2 seconds, 3 meter per second. At the end of 3 seconds, 5 meter per second. At the end of 4 seconds, it is 7 meter per second. Speed gradually increases. So therefore, speed time graph is a straight line here, inclined to time axis. That means if a body moves with variable speed, position time graph is a curved one. অলপ বেকা হ'ব position time graph টো, straight line নহয়. And speed time graph is a straight line inclined to time axis. Is it okay? Now we want to calculate what is the average speed in different intervals of time from this position time graph. Or we want to study the basic use of position time graph in case of variable speed now. Have you seen it? This is the position time graph for variable speed that we have drawn. So this is position of the body at time t1. This is another position of the same body at time t2. So what is position? It is at a distance s1 from the origin. What is position B? At a distance s2 from the origin. So therefore, what is the time interval? t2 minus t1. Now, what is the distance travelled during that interval? It is BC. Delta S is S2 minus S1. Because if this is S1, this is also S1. So what is distance travelled? S2 minus S1. So therefore, in this interval, what is average speed? It is delta S by delta T. What is delta S? Delta S is BC. What is delta T? AC. But at this moment, I want to draw the graph for you. Otherwise, it is a complex case for you. It is like this, yes or no? So this is T1 and this is T2. This is A, this is B, and this is C. This is called delta S. Delta S is S2 minus S1. Body moves according to this curve. This side distance, this side time. X-axis represents time. But now, this is not the right angle triangle. Okay, what is average speed? It is delta S by delta T. What is delta S? BC. But this is not the right angle triangle. Therefore, we cannot write tan theta at this moment because angle made by this curve with this line, with this parallel line, with this line which is parallel to time axis is not constant at different position. Because what is triangle? In a triangle, all the three sides, this should be straight, this should be straight, this should be straight. Three straight lines intersect each other, enclosing some area from the triangle, is not it? But if I join these B and C, now it becomes a right angle triangle. What is dotted line AB called? This is called the chord. Chord is a part of the curve, is not it? Chord is a straight line which joins any 2 points on the curve. But if I take now this particular case, now it is a right angle triangle. So we may write theta here. So what is BC by AC? It is tan theta tan theta means it is the slope of the chord. It is the slope of the chord of ST graph. ST graph. It is the slope of the chord of ST graph. Is it clear to you? So again I have written here, you just see, V average is delta S by delta T, BC by AC. Body moves according to this line, but this is not a right angle triangle. Therefore, I have to join A and B with a straight line. This straight line is also called a chord. Now ACB, it is a right angle triangle. So therefore, what is average speed? It is the slope of the chord of the distance time graph. But at this moment, if I take the B point somewhere here, that means I want to make delta T tends to 0. If delta 2 tends to 0, then what happens? B tends to A. That means B comes somewhere here. B comes somewhere here. So in that case, what is the chord? What is this chord? This chord becomes a tangent. Yes or no? When delta T tends to 0 in this particular case, so under that limiting situation, B has to come very close to A. That means this T2 will be very close to T1. Very close to T1. I think in the last class, when we discussed about the instantaneous speed, I said that the time interval should be 1 second and 1.0001 second. Time interval should be 1 and 1.0001 second. That means this T2 will be very close to T1, because in the graph it is not possible to represent the point separately, which is slightly away from T1 at an interval of 0.0001. So under that situation, B comes very close to A and this chord becomes the tangent at the point A. Because B point almost superimposed, not exactly. B point is very close to A, therefore this time interval is very, very small. That is called delta T tends to 0, and our average speed tends to instantaneous speed. Can you remember the definition of instantaneous speed? It is the speed of the body at a particular instant. It is the speed of the body at a particular instant. That means under that situation, delta T tends to 0, or it is said that it is the limiting value of average speed. It is the limiting value of average speed when the point B is very close to A or delta T tends to 0. I want to again draw the graph for you so that it is clear to you. Say this is the ST graph. This is the ST graph of the body. This is the ST graph of the body. So this is T1. This is A. And this is T2. Initially this is B. And this is the chord AB. This is the chord AB. I slightly extra plotted this line. When this delta T tends to 0, then what happens? This point B comes very close to A. As a result, the chord AB becomes, this chord AB becomes tangent at the point A. The chord AB, when delta T tends to 0, that means T2 very close to T1, B tends to A. Then what is the initial angle? So this was the initial angle. This angle now change to angle phi. Definitely in my situation, the angle decreases. Initially angle is theta, now angle is phi. That means when delta t tends to 0, B comes very close to A, the chord AB becomes tangent at A, therefore the angle theta, which initially makes by the chord with time axis or with a line which is parallel to time axis, becomes phi. Theta tends to phi. Therefore, instantaneous speed is equal to limit. It is the limiting condition of the average speed when delta t tends to 0. So therefore it is the limit when delta t tends to 0. When delta t tends to 0, theta tends to phi. Can you remember in the previous class what we have written? Average speed is tan theta, where theta is the angle made by the chord. Average speed delta s by delta t is tan theta. So delta s by delta t is tan theta. But here we put the limit when delta t tends to 0 or B comes very close to A. So under that situation, the chord becomes the tangent. This chord AB becomes tangent. So therefore the angle theta becomes phi. So therefore VI is equal to, this is written as ds by dt. This is called differential coefficient of s with respect to t. ds by dt is equal to tan phi. What is tan phi? It is again the slope. But what is phi? Phi is the angle made by the tangent. So it is the slope of the tangent at A or at any point, at A or at time t1 to the ST curve. That means whenever a body moves with variable speed at different instant, speed of the body is different. So what is average speed? Average speed is the slope of the chord of distance time curve. But what is instantaneous speed? It is the slope of the tangent at point t1, at time t1 or at point A to the distance time curve. Okay? Now, this was the curve, yes or no? This was the curve. If someone asked, this is the curve. If someone asked to calculate instantaneous speed here, so what you have to do? You have to draw a tangent here. You measure this angle with the help of protractor. You will get the instantaneous speed, tan theta or tan phi. Now you say someone asks you to calculate instantaneous speed at t2. Draw a tangent here. Say this angle is 30 degree, this angle is 60 degree. So what is instantaneous speed here? Tan phi again, tan 60 degree. That means since the body moves with variable speed at different instant, the angle made by the tangent are different. If someone asks to calculate instantaneous speed here, so what you have to do? You have to draw a tangent here. So at different instant, at different position of the curve, the tangent makes different angles, therefore instantaneous speed are different. That is why body is said to move with variable speed. Okay? But if we want to calculate what is the instantaneous speed in our previous class, so this is the distance time graph. Yes or no? This is the slope of the position time straight line gives the average speed or uniform speed when the body moves uniformly. So in this case, why we are not calculating the instantaneous speed from the graph? Because if I take delta t tends to 0 here, then what happens? B comes to A according to this curve. Therefore, angle theta always remains constant. Therefore, instantaneous speed at different instants remains constant, tan theta, and that is why it is called uniform speed. In this case, if I take different time interval, angle theta remains constant. So tan theta remains constant, therefore speed remains constant. This will be clear again from this particular curve, from this particular case. So this was the example of uniform speed of our previous class. You just see different interval, speed is constant. Here interval is 1 second, here interval is 4 seconds, then also speed constant. Here interval is 2 seconds, then also 3 meters per second. So that is why it is uniform speed. And since it is uniform speed, you just see here, 1 second interval, 3 meters per second. At 4 second interval, again 3 meters per second. 2 second interval, 3 meters per second. So at different intervals, the ratio of distance traveled to the time taken remains constant in this case. So that is why in this particular situation, we are not calculating the instantaneous speed. That I derived here separately. Because in this case, if I want to calculate the instantaneous speed, or if I call delta t tends to 0 at this moment, then what happens? B comes very close to A according to this curve, therefore angle remains constant. But in this case, in the non-uniform speed, if B comes to A, B will come like this, yes or no? B will come like this. Since B will come like this, at different intervals, tangent makes the different angle. Yes or no? Tangent makes the different angle. So therefore, at this moment, instantaneous speed was different. Is it okay? Is it clear? Variable speed, position time graph is a curve 1 and the speed time graph is a straight line 1. It may be sometimes different shape of line, but according to this equation, this is the position time graph and this is the speed time graph. Okay? In case of position time graph, if we have to calculate average speed between time t1 and t2, then what we have to do? Draw a chord joining the position A and B at time t1 and t2. Then you calculate what is the angle made by the chord with time axis. Then you take simply the tan theta. Therefore, slope of the chord of distance time curve gives you the average speed in case of non-uniform speed. And in case of instantaneous speed, what we have to do? We have to find out the tangent. The angle made by the tangent. Say we have to calculate the instantaneous speed at the point A. Draw a tangent at the point A. Then you measure the angle made by tangent with time axis. Then the slope of the tangent gives you the instantaneous speed. With this, I stop the class today. In next class, we discussed about the velocity, average velocity and instantaneous velocity. Since we are discussing about the motion in straight line, if the body never returns back, distance and displacement are same. So therefore, lot of conditions of speed time graphs, lot of condition of the average speed and uniform speed or instantaneous speed is equally applicable in case of velocity also. Okay?